This video is going to look at the respiratory system, and these are the things you need to know that are listed on your specification. So make a list of them at the start of your notes. You need to know the pathway of air, so how it gets from your mouth and nose into your bloodstream. You need to know about gaseous exchange, the different types of blood vessels, the mechanics of breathing, so how we actually breathe, and also how to interpret a spirometer trace. Now we're going to do a lot of that in lessons, but you should know what one is by the end of this video. So first we're going to look at the pathway of air. The first thing that happens is you breathe in, and the air goes through your mouth and nose and into your trachea. And the inner surface of your trachea is covered with something called cilia, and they catch all of the dust particles and stop them from going down into your lungs. And then the trachea divides into two bronchi, and they further divide inside the lung. And the small bronchi then divide into bronchioles, which are very narrow and less than 1 millimeter in diameter. And at the end of those bronchioles, you have the alveoli. So if we look at this drawing here, you've got the air going in through the mouth and through the nose at the top. It goes down your trachea, your windpipe, and then it divides into the two different sections here and go off into your lungs. Okay, into your little bronchioles here and up into your alveoli at the end. There's an image down here, just to the right, where you can see your alveoli, or those air sacs at the end of the lung. Now, the alveoli are really important. They are air sacs, and their main function is gaseous exchange. When you use that term, you mean it gets oxygen from the lungs into the blood, but it also removes carbon dioxide from the blood and into your lungs so that you can breathe out carbon dioxide. Now, this gaseous exchange, where the oxygen and carbon dioxide leave the blood or go into the blood, happens down a concentration gradient. So it goes from an area of high concentration, like having high levels of oxygen in the lungs, to an area of low concentration. You've got low concentration of oxygen in the blood, so the oxygen moves from where it's high to where it's low. And the opposite happens with carbon dioxide. You've got a lot of carbon dioxide in your blood, only a small amount in your lungs, so the carbon dioxide moves from the blood into the lungs so you can breathe it out. And this process is called diffusion. And it's a passive process. You don't have to think about it, you don't have to do anything about it. It will happen naturally. Now, there's a lot of factors that assist with gaseous exchange in alveoli. So what this means is there's a lot of different structures in the alveoli that help it with gaseous exchange. For example, they're very small, but there is a large number of them. So overall, there is a large surface area in the lungs for gaseous exchange to take place. Both the alveoli and capillaries that cover the alveoli are very, very thin. So there's only a very short distance between the alveoli and capillary. So it doesn't have a long distance to travel. Oxygen, carbon dioxide have a very short distance to travel. That can happen really quickly. Also, you've got a layer of moisture in the alveoli, and that can help with gaseous exchange as well. The important thing is the alveoli are covered in capillaries. Okay, so you've got a rich supply of blood constantly being surrounding the capillaries, of oxygenated blood, deoxygenated blood, the oxygen going in, the carbon dioxide coming out of the blood. And the gases always move from an area of high to low concentration. Oxygen moves from the alveoli, where there's high oxygen, into the blood, where there's low oxygen. So you've got all these different things that help an alveoli get oxygen into the blood. Now we're going to have a quick look at oxygen transport. And oxygen, as we said, goes from an area of high concentration to an area of low concentration. And it gets into the blood via the capillaries that surround the alveoli. And then the oxygen combines with hemoglobin, and that forms oxyhemoglobin. The hemoglobin is a pigment which is found inside the red blood cells, and that pigment will bind with oxygen, forming oxyhemoglobin. And it's this hemoglobin inside the red blood cells that lets us transport oxygen around your body. Carbon dioxide is also carried in red blood cells and also combines with hemoglobin. Now we're going to move on to breathing. There's a few key terms you should know. We've got inspiration, which is where we take air into the lungs. Okay, so the volume of the lung cavity and the chest cavity increases, and we can take air in. We've also got expiration, where we expel air from the lungs, so breathing out. And we do this by reducing the volume inside the chest cavity. So if we squeeze in on the chest cavity, we end up breathing out. If our chest gets bigger, we take air in. And both inspiration and expiration involve the use of two really important muscles, your diaphragm and the intercostal muscles. If we have a look at this drawing here, you can see the diaphragm at the bottom. The diaphragm sort of goes underneath your rib cage. And when you breathe in, the inhalation here, you've got your diaphragm which pulls down. So it contracts, pulls down, and it increases the area inside your chest for where you can get more oxygen in. And when we breathe out or exhale, the diaphragm relaxes, it pushes up, and it tries to force air out of your lungs. Your intercostal muscles are these little red muscles inside or in between your ribs. Now, if you ever eat spare ribs, then that is what you're eating. You're actually eating intercostal muscle. And when the intercostal muscles contract, they pull the rib cage up. So that's during inhalation. They'll contract. It moves your rib cage up in your chest to make more room for more air to go into your lungs. And when we exhale, your intercostal muscles relax and it collapses and sort of closes in on your lungs. So it forces more air out of your lungs. So your intercostal muscle and your diaphragm contract when you breathe in and they relax when you breathe out. So the diaphragm, when we are doing inspiration, when we're breathing in, your diaphragm will contract and it will flatten. Your intercostal muscles will contract and lift those ribs upwards and outwards. And the whole point of this is to increase the size of your chest cavity. And your lungs follow the movement. So as your chest gets bigger, your lungs get bigger as well. And then air gets drawn into your lungs. Expiration, the reverse happens. So your diaphragm and your intercostal muscles relax, and your diaphragm returns to its dome shape, so it pushes up on the lungs. And the ribs start to descend because your intercostal muscles are relaxing. And overall, it decreases the volume of your chest. That increases the pressure of the air in your lungs, and it pushes and forces that air out of your lungs, and you breathe out. Now, certain things happen during exercise. Obviously, your breathing while you're sitting here watching this video is going to be very different to you playing a football match or basketball match or going for a run. So during exercise, we have other muscles. You have to know the names of these, so make sure you spell it correctly. When you breathe in, another muscle called the sternocleidomastoid muscle and also your pectoral muscles, they also work. The sternocleidomastoid is sort of found running down your neck. And your pectoral muscles, you know. So what happens is they contract and they again help the size of your chest increase. So more air can enter your lungs. An expiration, your abdominals contract. So it helps force air out of the lungs and speeds up expiration. It's just about remembering you've got extra muscles, the sternocleidomastoid, the pectoral muscles, and the abdominal muscles that all help with breathing in and breathing out. Right, we've got a load of different key terms here that you need to know. They're all different types of lung volume. Now, a spirometer is a way of measuring lung volumes, and we're going to look at a lot of that in our next lesson. But I want you to get down the next key terms. Your tidal volume is the amount of air you breathe in or out in a normal breath. How much air you're breathing in, how much air you're breathing out. Your inspiratory reserve volume is how much or the amount of extra air that you can breathe in. So if you have to breathe in as much as you can, that's your inspiratory reserve. Your expiratory reserve is the amount of air you can breathe out. So if I ask you to breathe out as much air as you possibly can, that's your expiratory reserve volume. And finally, you've got something called your residual volume. That's the amount of air that's left in your lungs once you've breathed out as much air as you can. And there will always be a little bit of air. You can never get all the air out of your lungs.